Good evening, fellow students. We're going to go ahead and charge forward with some new stuff in trigonometry, basically with triangles and using right triangles specifically. So before we begin, it's always important to define what a right triangle is. And so today's lecture is going to be called Right Triangles Used to Evaluate Trigonometric Functions. Now, right triangles are used all the time. They're really, really handy to have around. They're used a lot in measuring distances and heights, surveying things, really, really powerful. And it's important to realize that this all relates back to the unit circle. Now, the unit circle, we're going to start here, is, if I draw my unit circle out here, remember it's a radius of 1. And I'm going to keep referring back to the unit circle in the next few lectures because I really want to try to make that relationship extra clear for you guys. Now, say I've got an angle here, call it theta, where theta is equal to pi over 3. And of course, because it's radians, pi over 3 radians, that means that this arc length right here is also going to be pi over 3. So I've got some point right here, point P, and it's going to have an x value and a y value. And of course, if you remember from your unit circle, you know that P is going to be at 1/2 root 3 over 2. Now, if I draw a line down to here, and I create a right triangle right here, here I've got some x value, because this is my x-axis, and I've got some y value, which is going to be my height. Now, the x value, of course, that's going to be right here, this x value. So this distance right here is going to be 1/2. So x is going to be equal to 1/2. Now, our y value here is going to be the height. Now, the height is going to be equal to y is going to be equal to, in this case, it's going to be square root of 3 over 2. Now, what is the length of my hypotenuse of this triangle? Let me draw my triangle a little bit bigger here. So I've got this right angle here. I know that this is 1/2. I know that this is square root of 3 over 2. Now, I could do Pythagorean theorem, a squared plus b squared is equal to c squared, or just realize that the hypotenuse is just the radius of my unit circle, and I know that the radius is going to be equal to just 1. Now, if I went ahead and I did my a squared plus b squared is equal to c squared, or in a previous lecture, we said it's going to be x squared plus y squared is equal to 1 squared, right? But I'm not going to square it. I can figure that out right from here. So I can say I've got 1/2 squared plus root 3 over 2 squared is equal to 1. So here I've got 1/4 plus, then if I square the 3, square root of 3, that just becomes 3. And if I square the over 2, that just becomes 4. So I've got 1/4 plus 3/4, and sure enough, that is 100% equal to 1. Now, of course, this is also related to, tying it once more back, to cosine squared plus sine squared is equal to 1, or sine squared plus cosine squared, because you can write these around. Whereas the sine is the y value, and so sine squared would be y squared, and cosine squared is going to be the x value, or cosine squared is going to be x squared. Now, what we're going to be talking about is, instead of just the unit circle right triangles, we're going to be talking about some larger right triangles. And this is going to start sounding really, really familiar. If you guys remember SOHCAHTOA, that's exactly what we're talking about. Now, instead of the SOHCAHTOA, however, we're going to expand it into not just the sine, the cosine, and the tangent, but I want you guys to be comfortable doing the cosecant, the secant, and the cotangent as well. So I want you guys to draw a big triangle down here. And this is going to be sort of our master triangle with a right angle. Make sure your right angles are always labeled with a little box there. So we've got A, B, and C. This is how I'm going to label them. And we've got some theta. And this is, A is also known as the opposite. This is also the adjacent. And c, of course, is also the hypotenuse. Now, if you remember SOHCAHTOA, SOHCAHTOA, great little mnemonic. I remember I learned this probably in 8th grade, never ever forgot it to this day. So of course this just says that the sine of this angle is the opposite over the adjacent. I got a little smudge there. So the opposite is, in this case, is going to be my A, or sorry, the opposite over hypotenuse. And so in this case it's going to be A divided by C right here. A divided by C. Now, if I expand this out, I can also do the cosine. Cosine in this case is going to be B divided by C, and tangent is also going to be opposite over adjacent, which is going to be A divided by B. Now this does relate back to the unit circle. I'll let you guys figure out what that relationship is, or we can delve into that a little bit more in class. However, as I said, I also want you guys to know the reciprocal relationships here, in which case is going to be the cosecant of theta. Remember, in the sine and the cosecant are just reciprocals of each other, so instead of A over C, this is just going to be C divided by A. And the opposite, or the reciprocal of the cosine, is just going to be the secant of theta is going to be C divided by B, instead of B over C, C divided by B. And the tangent, oops, sorry, not the tangent, the cotangent of theta is just going to be B divided by A. Now, what use can I do with this information? How can I use this information? So I'm going to give you a triangle, and I want you to figure out what each of the 6 trigonometric functions are in this example. So let me go to a fresh page here so we've got lots of room. So example 1. Okay, so the triangle I'm going to give you guys right here, it's not going to be a unit circle triangle, right, with 1/2 the square root of 3 or whatever, but it's just going to be 5 and 12. And here I've got some angle theta, and I want you to find the 6 trig functions of theta. Now, first thing I'm going to realize is if I'm going to do any sort of SOHCAHTOA, I'm missing this value right here. I'm missing my hypotenuse, or as I have it written, my C value. And so I just need to do that really quickly. Oh, that's a right triangle. I'm sorry. Just like I was reminding you guys, I forgot my little box, but I remembered it now. First thing I need to do is do a squared plus b squared is equal to c squared. So my a is going to be 5. Let me write it up here. A squared plus b squared is equal to c squared. So I've got 5 squared plus 12 squared is going to be equal to, doing this, I'll say 25 plus 144, which is going to be equal to 169. Now, of course, 169 is going to be equal to c squared. I square root both sides. I find that c is going to be equal to 13. You guys might remember this from one of the problems we did in class yesterday. This 5, 12, 13 right triangle. Very special one there. So now that I know what my c is, I can say that a is going to be equal to 5, b is going to be equal to 12, and c is going to be equal to 13. So now I just need to fill it in using this information that we just wrote down here: sine, cosine, tangent, cosecant, secant, and cotangent. Okay, so the sine of my angle theta is going to be equal to a divided by c. In this case, it's going to be 5 divided by 13. Done. Now my cosine theta is going to be b divided by c, or just 12 divided by 13. Done. Tangent of theta is going to be a divided by b, or 5 divided by 12. I'm just reading these right off of my previous notes right here. A divided by c, b divided by c, and a divided by b. Now I'm doing the other thing, or the other ones are reciprocals. The cosecant, I can either remember what I've got written down in my notes, or I can just take the reciprocal of what I've got here. So instead of 5 over 13, I've got 13 divided by 5. and not the cos. It's going to be the secant of theta. It's going to be 12, instead of 12 divided by 13, just do the reciprocal, 13 divided by 12, just flipping it over that bar. And the cotangent is going to be equal to, instead of 5 over 12, we get 12 divided by 5. Just like that. Excellent. So 100% correct answer right there. Let's jump into a second example. Very, very similar. Not a whole lot different. But however, this triangle that I'm going to give you, also a right triangle, I'm going to give you A is 1, C, or the hypotenuse, is going to be 3, and this time you don't know that side. Okay, and so same thing. Here's an angle, right? I've got my little box there. Now I need to figure out the same 6 trig functions of theta. So here I start with a squared plus b squared is equal to c squared. And so instead of knowing a and b, I don't know a and b, I know a and c. So I'm going to say 1 squared plus b squared is going to be equal to 3 squared, or 1 plus b squared is going to be equal to 9. So doing a little bit of quick algebra, subtracting 1 from both sides, b squared is going to be equal to 8. If I square root this, so I've got b is going to be equal to square root of 8. Or if I do my tree over here, I'm going to try to reduce this. I see I've got some 2's I can pull out, but then 1, 2 has to stay in. So b can also be equal to 2. I can pull these 2's out, square root of 2. Going back to some of the stuff that we learned earlier, we reviewed earlier. Now this isn't my answer, of course, this is just what b is equal to. But now that I know what a is equal to 1, b is equal to 2 root 2, and c is going to be equal to 3, now I can figure out what my 6 trig functions are. So the sine of theta is going to be equal to a divided by c. I'm just going to rewrite them this time around because I skipped it last time. So I'm going to get 1 divided by 3. Done. Cosine of theta is going to be equal to b divided by c, which is going to be equal to 2 root 2 divided by 3. And the tangent of theta is going to be equal to a divided by b, which is just going to be 1 divided by 2 root 2. Now, I don't like the radicals on the bottom, so I'm going to get rid of them. So I'm going to multiply, just by root 2 on both. And this is going to be equal to root 2 divided by 2 times root 2 times root 2. This is going to be 2 times 2, which is just going to be 4. Awesome. So I've got those 3. Now let's do the cosecant of theta, just the reciprocal of this. It's just going to be 3. 1 over 3, reciprocal is just going to be 3. The secant of theta. Now this one, I've got 3 over 2 root 2. I've got a radical on the bottom, bad news. So I'm going to multiply the top and the bottom by square root of 2 over square root of 2, or top by square root of 2 and the bottom by square root of 2. And so on the top I get 3 root 2, and on the bottom I get 2 times root 2 is just going to be 4. So 3 root 2 over 4 is the secant, a little bit tricky. And the cotangent of theta, when I flip this, I'm going to see I've got a reciprocal on the bottom. But if I remember, I go back here to my a over b. And if I just say b divided by a, so root 2 over 1, I can just say that the cotangent of theta is going to be 2 root 2. Now, if you want to flip this and multiply it both the top and bottom by root 2, that's totally fine. You'll end up with the same answer after you've simplified. So here's the 6 trig functions based off of my right triangle. Fantastic. All right, I'll leave you there, seniors, and we'll pick this up in class tomorrow. See you there.